Hand Gesture Vocalizer using STM32F103C8T6 BluePill Development Board. Hi everyone, my name is Dr. Konark Sharma. In this lecture, we will learn about the basic overview of Hand Gesture Vocalizer using STM32F103C8T6 BluePill Development Board from Shashi Yadav, Pallavi Kumari and Shreya Singh. Upon completion of this lecture, learners will be able to understand about the basic overview of Hand Gesture Vocalizer using STM32F103C8T6 BluePill Development Board. So, let's get it started.
KONARK'S research, subscribe now.
Greetings everyone, this is group 19 and our project is Gesture Vocalizer. We are in total 3 members. I am Shashi, roll number 1703.
I am Pallavi, roll number 1729.
I am Shreya, roll number 1734. As previously mentioned by my group member, our project Gesture Vocalizer utilizes STM32 to convert hand gestures into speech using motion detectors.
Our project is basically made for hospitalized patients to help them convey their basic needs effortlessly.
Though our project provides basic functionalities, it is user-friendly and cost-effective, and therefore a better alternative to current existing solutions.
Let's see how our gesture vocalizer is better than the existing solution. First of all, the compact and lightweight design. The existing solution appears bulky due to large display and exposed wiring, while ours is focused on a compact, glove-integrated design with minimal protrusions for better comfort and wearability, especially for long-term use. Secondly, assistive usability. The existing solution likely requires visual attention due to the display-based communication, while ours provide auditory output, making it ideal for visually impaired or completely bedridden patients who may not be able to view displays. Third, in existing solution, fixed gestures might be pre-programmed, difficult for user to update or customize without reprogramming, while in our solution, it is flexible to modify or expand gesture and making it adaptable to use. And last but not the least, the cost effectiveness with more features.
We have efficiently divided the workload between the 3 of us, and each member has completed their work on the timeline. After weeks of research and discussion with our mentor, Dr. Konark Sharma, we came to the conclusion about how we are going to implement this project.
So after the completion of research work, we went for the hardware. First, we decided the components, and next, we have made the circuit.
For the software part, we started exploring different softwares, for example, Arduino IDE, STM32Q programmer, and we concluded that the Arduino IDE will suit the best here.
Let's see the components. So, we have used STM32 microcontroller, which is also called BluePill, and this is the DF mini player, and we have used SD card for this, which is of 4 GB. This is speaker. This is the battery. This is MPU 6050 for motion sensor, and these are the flex sensors.
Now let's see the connections.
Let's connect the battery first to the circuit, connecting the positive and the negative terminals. Here is our speaker. Let's connect this too. Our connection is done here. Since all the LEDs are on, we can say our circuit is completely connected.
Please give me water. I need my medication. Please give me water. I'd like the light off. Please give me water. I need to use the restroom. Please give me water. I feel uncomfortable. Please give me water. I need to be moved to the chair. Can you call the doctor? Please give me water.
Finally, we would like to cooperate with you according to the best of our knowledge. Keep your feedback and suggestions coming. They help us to provide you quality work that resonates with your needs and requirements. Thanks much for sharing your kind suggestions. Keep healthy, keep learning, and keep growing.
KONARK'S research. Subscribe now.